System dynamics models are built based on the system's structure and use differential equations to describe processes within. But changing the values of parameters in the equations, or changing the strength of feedbacks, will not be adequate if a system is undergoing a major change. Gary Polhill and his colleagues provide a clear overview of the problem and paths forward. They emphasize that when using a systems dynamics modeling approach to study systematic changes, the model's ontology itself may need to change. New state variables, feedbacks, or system boundaries may be needed. Thus, some researchers shift to a different modeling approach. A somewhat more flexible modeling approach is agent-based modeling. Rather than assuming a system structure up front, like system dynamics models, ABM begins by focusing on the behaviors of the individual components, or agents, in the system. These agents shape and change the state and structure of the system over time. Importantly, it allows for diversity in behaviors for a given agent type. The rules that govern an agent's behavior are generally drawn from a distribution function. ABMs also allow for spatial structure and processes, so it is useful in studying dynamics across landscapes or networks. A useful example can be found in the work of Nick Maglioka and his colleagues, who used an economic agent-based model of land use to explore the importance of economics in the spatial patterns of development over time.
Understanding dispersed patterns of urban development is important for designing policies that take into account the environmental impacts of sprawl. Our model had three types of agents: consumers who purchase houses of different types in different locations, a developer who converts undeveloped land into residential housing, and farmers who choose between farming and selling their land. The model simulated a series of market events including buying land, building houses, and setting asking and bid prices. Agents' decisions were governed by a set of mathematical algorithms. And these are learning rules based on cognitive models so that consumers, developers, and landowners could adapt over time as they would in the real world. We found that early development patterns are determined by agricultural land values, but eventually over time become dominated by farmers' land price expectations. This work pointed to the importance of people's expectations and behaviors. It highlighted the needs to take into account more than just economics.